Hello, everyone. Welcome to this very first lecture in the Research Skills course on analysis of variance. So you're looking at the very first lecture in this course that corresponds to week 1. And actually what I'm going to present you today in this lecture will be exactly the same as what we would typically do in the very first meeting. So typically we would be sitting in a nice computer room at university. And before the break, so the first 45 minutes or so, I would be talking about content of the course and also the first topic, so the topic for the first week. And then after the break, typically you would be doing practice assignments, and I would be walking around and giving you some feedback, answering your questions. Of course, the second part cannot take place in the same way at the moment, of course, but the very first part, so the lecture, we can have digitally. So that is what I will present to you now via this lecture. So I am going to share my screen now, such that you can also see the slides. There we go. Let's see if this works. Right, so there we are. So welcome to this course, as I said. What I will discuss today, what I present to you today in this very first lecture, first of all, the practicalities of this course and how we're going to do this. Now we have to do this in a digital way. So I'll talk about the content of the course and its setup, the aims of the course, of course, for instance, the topics of each week, the readings that there are for you to do, some practicalities, and of course, I'll also say something about the assignments and the exam. Once that's done, we'll look into the very basics of multiple regression and mediation analysis. So this is the topic for this week in this course. And then, as I said, typically after the break, there will be this, what was an in-class assignment. Of course, we can't do that in the current setup. So we're going to do this via Canvas. So on Canvas, you find the assignment for this week. It's just a practice assignment. You can do it for yourself to get a better understanding of the topic. And also the answers will be on Canvas. But please only do it after having watched this lecture, of course. Right. So let's talk about the content. Well, right, so this is me. Nice to meet you. Probably many of you haven't seen me before. So I'm not teaching in the bachelor program and also not in the pre-masters. But I do teach another course in the masters on virtual, augmented, and mixed reality. So you might know me from that course that took place during block 2 most recently. And I'm also teaching in the research master, but that's perhaps less relevant for most of you. So when I'm not teaching, I'm doing research. I do a lot of virtual reality research on different topics, but they all have to do something with language. And they also more or less all have something to do with the brain and cognition. So I'm very much interested in, for instance, if people talk to each other, what happens in their brains. All that is actually not so relevant for this course, because in this course, of course, we're going to talk about statistics. Right, let me present you with the course aims for this course. So every course typically starts with a discussion of those course aims, right? So if you finish this course successfully in 6 or 7 weeks from now, you will be able to do a lot of things. So first of all, you will be able to formulate hypotheses and also propose an appropriate research design based on the description of a study or a research question. So you might think that this has not much to do with statistics, right? Well, but of course, before you are going to collect your data, for instance, for your master's thesis, or before you're going to do the analysis of a data set, of course, it would be very nice if you already have a research question, a research design in your study, some hypothesis. What do you expect in your study on the basis of the data that you're going to collect? So we're simply going to practice this. So how do you formulate a nice hypothesis? How do you formulate a nice research question before you start looking at your data, or even before you start collecting your data? Once you have data, of course, you can do many analyses. So there are hundreds of different types of analysis that you can do. Of course, it's important that you select the right analysis. to answer your research question on the basis of the data that you have. So that's also something we're going to practice. So in many cases, you will get a data set, and the question will be, what now is the exact appropriate statistical technique that you can use? What analysis should you use to answer your research question? And we'll mainly focus on continuous data. Continuous data, you might still know this from an earlier statistics course in the bachelor and the pre-master. Continuous data is the opposite of categorical data. So categorical data are very easy to explain. So a typical, classic example of categorical data is, for instance, pregnancy. So if you think of people in general, they can either be pregnant at this moment, or they cannot be pregnant. So actually, there are only two output data points there. Either someone is pregnant or someone is not. So this is very categorical. It's either one thing or the other. It can also be 3 categories that are categorical, or even 4, but often there are not that many different categories. Either one thing or the other, or something different. Continuous data is the opposite of this. So in the case of continuous data, there are all sorts of values possible. So here the classical example is people's height. So people's height is generally not just one thing or the other. It can have many different values. So you can be, for instance, 180 centimeters tall, or you can be 176 centimeters tall. Or some people are relatively small, they might be 160 centimeters tall. Other people might be relatively tall. They could be maybe even 210 centimeters tall, but there are all those different possibilities of outcome values that are continuous. And often those outcome values are normally distributed, which means that there are a couple of values that are relatively low, there are a couple of values that are relatively high, but for most people, it's sort of the average, right? So height in centimeters or even in millimeters, if you want, is an example of continuous data. Well, for those types of data, we're going to look at different statistical analysis. We'll focus on different types, for instance, factorial ANOVA, factorial analysis of variance, repeated measures ANOVA, also multiple regression analysis, the topic of today, including mediation and moderation models. It's perfectly fine if you don't know what this all means at this moment. I promise you, in 6 or 7 weeks from now, you will understand what it means, and you will have practiced with carrying out those different analyses. We'll also look at investigating data for testing violations of underlying assumptions for each of those different analyses. So here you might also remember from previous statistics classes that you can very easily carry out an analysis in SPSS. You can just, if you have a data set, you can just run the analysis. But it is important to be sure that the outcome that you get from SPSS is reliable, that your results are reliable. And to confirm this, every analysis has to meet a certain number of underlying assumptions. And we'll look at those assumptions. And if those are not violated, then you can be sure that your results are actually interpretable and reliable. We'll look at that. And then finally, once you have done your analysis, of course, you would like to report those. So we're going to practice how to write this up. So if you've done your analysis, how do you nicely write this up? Also as a practice for your master's thesis, for instance. All right, so here you see the planning of the course. So as you might know by now, this 4th block will consist of 7 consecutive weeks. Here you see the start date, so the Monday of each of those weeks. And you will also see that every week there will be a different topic. And the best way to look at this for this course is that there are actually 2 blocks of 3 weeks in which different activities take place. So in the first 3 weeks, we're going to look at those different analysis techniques that you can use, but we'll look at the basics. So you'll get to know the basics of those analysis techniques, and we'll do some relatively short practice assignments. Then in the second block of 3 weeks, we're actually going to look at the same techniques again, But now we're going to practice more. If you want to understand those techniques, those measures, those analysis, basically you just have to practice a lot. So basically in the second block of 3 weeks, that's what we're going to do. We're just going to do a lot of practice assignments. And then finally in the 7th week, there's just a Q&A session in preparation of the exam. So there will be no assignments anymore, just preparation. If you have any questions left, this is what you can ask during this 7th week. This is also something you can find on Canvas. So all information about the course is also completely on Canvas. Right, then some more information that you typically as students also find important. So to pass this course, there are basically 3 components that will make up your grade, your final grade. There are 2 assignments during the course. The first is a relatively short assignment that counts for 15% of your final grade. Then there's a second, somewhat longer assignment that counts for 35% of your final grade. And then there's an exam. And typically this exam would take place in a computer room, just to make sure that you're not collaborating on this and that you're not discussing the answers of each question. Of course, this is something we can't do at the moment. So I'm going to make a new exam, which we will call the take-home exam, or actually even better, the stay-home exam. And this will take place in any case after this block, right? So after this block, as you might know, first there will be the exams of block 3 that have been postponed. And after that, there will be the exams for block 4. So about probably 2 or 3 weeks after the block, there will be this stay-home exam. And the exact date hasn't been announced yet. So we're just waiting on this date from the schedulers. Once I know it, I will communicate it to you. And then probably on this one date, I'll put this stay-home exam online via Canvas. And then you'll have a couple, 2 or 3 hours or so to finish it just by yourself at home. Hand it in, and then this will count for 50% of your final grade. Right, so here's the same information, but then differently. The content of this first assignment will be an analysis plan. So you won't carry out any analysis yet for this specific graded assignment. You'll just make a plan in which you specify what you are going to do later. And you will get feedback on this plan from me. And then the second assignment will be actually carrying out statistical analysis and reporting them. And this will take place later during this course. Yeah, so more formal information, you need to get a 5.5 as a grade or higher for each of the 2 elements. So the assignments together on the one hand, and the exam on the other hand, to pass this course. And what's also very nice is that for all the assignments, except for the exam, you may work together. So it's actually even nice to work together. So maybe if you don't immediately understand something yourself, maybe your friend, your peer does understand it, so you can nicely talk about this. But for those graded assignments, it is important that you write up the answers yourself so that you don't plagiarize and just hand in the same thing compared to your peer. More information about this later when those assignments will become more relevant. Right, then there are some things that you will basically need. I hope you will have those already. So on the one hand, we're going to use this book by Andy Field, Discovering Statistics Using IBM SPSS Statistics. I'm using the 5th edition, which is the most recent edition. It may be the case that you yourself, for instance, have the 4th edition. My suggestion would be, in this case, don't buy the 5th edition, just stick to the 4th edition, but pay some attention to the chapters that you will need to read each week. So in the 4th and the 5th editions, the same chapters have different numbers. So in the 5th edition, a chapter has been added. Therefore, whenever I'm referring to a chapter in this book, I will also always name the name of this chapter, such that you can be sure, even if you use the 4th edition, that you're reading the right chapter. That's the book. On the other hand, there's also SPSS, of course. You will need SPSS yourself to carry out analysis. This course cannot be done without this. If you don't have this, if you don't have SPSS yourself, I would suggest going to SurfSpot. online. This is also something I've done myself a couple of weeks ago when I started preparing. And there for 10 euros, you can simply get SPSS. I got version 26. That's the most recent version. If you have a less recent version yourself already, you can also just use that. So there are not that many differences across the different versions. So if you have a version of SPSS, that's going to work. So those are the two indispensable things that you will need. Right, then let's talk about the different weeks in this course. So this week is week 1, obviously, and each week there will be different things for you to do. So at the start of each week on Monday, I'm going to send you an email with all the things that you should do during that week if you want to successfully pass this course. Before doing that, it's good to have some background knowledge. So I'm actually assuming some background knowledge because for you to take part in this master's program in general, you will have had to do a previous statistics course already. And I'm sort of assuming that you already know more or less what's now in chapters 2, 5, 6, and 8 of this book by field. So you see the names of those chapters also on this slide. So those are considered background knowledge. So those are really the basics that you will need. If you're looking at those chapters and you think, wow, I forgot most of it, it would be good to refresh it. So try to read it again, sort of to get all on the same page. But I'm sort of assuming that this is more or less basic knowledge that you already have. Right, so then for this week, the topic is multiple regression analysis and a little bit of mediation analysis. And as I said, for each week, there are different activities for you to undertake. For this week, it's the following. It would be reading chapter 9 in the book about regression and chapter 11, and especially for chapter 11, the part about mediation, because that's the topic of this week. So that's one thing. So reading those chapters. If you're reading those chapters and if you're listening to my video lecture and you think, well, I really have no clue what this is all about. I have really no idea. I really don't understand this. Then there are also some additional videos that you can watch on YouTube. So those are videos made by Andy Field about the different topics. So if you feel like you're having a hard time understanding those chapters in the book, you could additionally also look at those videos on YouTube. There, the same things are explained again, but in a different way with some practice assignments as well. So if you have a hard time understanding things, it would be good to also look at those videos to get your understanding a bit higher. Then there are those video lectures. So for this week, there's this lecture that you're watching right now. And typically, as I said, there's this in-class assignment. So of course, this is not in class this week. So this assignment will now be on Canvas. It's relatively short for this week. So I would suggest first reading the chapters and looking at this lecture. If needed, also look at those Andy Field videos on YouTube and then make this assignment on Canvas. Also, the correct answers for this assignment are on Canvas. So I would suggest to make the assignment first. It's not graded, right? This assignment is just a practice assignment for you to do to see whether you understand everything. First do it and then compare your answers with the correct answers that are also on Canvas. And in this way, you can sort of see whether you understand everything, in this case for week 1. Well, week 2, that's next week. That's more or less the same thing, different topic. Again, there will be 2 chapters for you to read. If you need them, there will be additional videos that you can watch. There will be a second lecture by me via Canvas, via the YouTube channel. And again, there will be an in-class practice assignment for you to do, sort of to check whether you understand things. That's week 2. Week 3, same thing again. So different topic, but again, there are chapters to read. If you need them, videos to watch, a third lecture, and another relatively short in-class assignment for you to check whether you understand everything. So those, for the first 3 weeks, those weeks more or less look the same every week. They're just different activities. Each Monday of each week, I will send you what those activities specifically are. And via Canvas, you can carry them out one by one. And in the second block, as I said, so weeks 4 till 6, it will be a bit different. So then it will just be practicing, practicing, practicing. So there will be practice assignments via Canvas. There will be no more new chapters to read. There will be no more new lectures. There will be no more new videos, because this is also how it typically goes if this course takes place on campus. There also in weeks 4 to 6, students come to the computer room, they start practice assignments, and I would be walking around typically giving feedback. So this is something now, of course, that we're also going to do digitally. So in those weeks, there are practice assignments for you to do, and there will be Q&A sessions digitally for all your questions. So if you have a question, if you get stuck, and if you're also your peer or your friend gets stuck, then please ask me this question, and then I'll be happy to answer those for you to move on. Right, to summarize, learning statistics is really practicing. That's also why it's not so super bad for this course to take place digitally, because most of the time, also when this course would take place physically, most of the time you would just be practicing yourself. All those things you need to do yourself anyway. And rather than being there in person giving you feedback, now I'll just be there digitally giving you feedback. That's the only main difference, basically. And as I said, each week there are several things for you to carry out: watching lectures, reading chapters, practice assignments, etc. Right, so in your timetable, in your schedule, there will be a planned meeting slot every week. So as you've noticed now, I'm just putting those lectures online, so you can watch them whenever you want to watch them. But we're going to use the weekly scheduled meeting times for Zoom meetings. So I'll send you a link. If you have any questions, for instance, this week you might have questions about the content of the course. During the scheduled lecture times in your timetable, feel free to join. If you have any questions, then you can ask them there, and I'll be around and answer those. And one other thing I would like to ask you is to send me a weekly email with questions. So for me, it's it's quite nice if I sort of know whether people are understanding things, whether you're understanding the content of the course or not, whether you are understanding the practice assignments. So what I would very much appreciate every week, if you have done all those activities, send me an email. If everything worked out well, just send me an email saying everything was perfectly clear, it all worked well. If that wasn't the case, if you have any questions, please put them also in your email. And then I'll answer those emails Friday afternoon. And if many people happen to have the same question, if something is unclear to many people, of course, I can respond to this by, for instance, adding another video with some more explanations, or explaining things in a different way. So all this I can do as long as I sort of know, as long as I sort of have a feeling what is going well and what is not going well. So therefore, please just email me via Canvas if you have questions. And in any case, on Friday afternoon, I'll go through all of those and answer those as quickly as I can. Right, so this is the content of the course. And basically everything I've just said is also on Canvas. So there's no need to watch this part of the video lecture again. Just look at the Canvas page. There's a relatively long welcome message with all information as well. And there's also a syllabus where much information is provided. So there you should be able to find all information about this course, how we're going to do it, what the assignments are, and so on. Right, so that's about the practical part. I hope that was all clear. Then the second part of this lecture, as it would also normally go, is about content. And the topic of week 1 is multiple regression, mainly, and a little bit of mediation analysis. So, right, let's just move on with that. I'll quickly have a drink some water. And let's get started with the real statistical content. Right, so let's start. The first topic is multiple regression, but before we move there, let's refresh some knowledge that you might have about simple regression analysis. Right, so in the case of simple regression analysis, what you typically want to know is the relationship between two variables. You could say basically the correlation between two variables. And let's look at a hypothetical example where you're interested in the relation between those two variables. One we will call internet efficacy. And this basically means how well people are using the internet. So most of us are very skilled, right? Very good in using the internet. We have a lot of experience. We're very good at this. But of course, there are also people who are not so good at using the internet efficiently. You can think of older people, for instance, people who find this difficult. And this is something you can measure. So you can, for instance, with a questionnaire or so on, you can get a measure for different people in how good they are at using the internet. That's our one variable. And then we'll also have another variable here, which is the willingness to use new technology. So some people we know are very willing to use new technology. They are very much into this. Other people are not so much into using new technology. This is also something you can measure. You can measure this, for instance, also with a questionnaire. How willing are people to use a new technology on a certain scale, for instance, from 0 till 100, or from -50 to +50. Right. So those are two concepts. Those are two variables. And now let's assume that you have the hypothesis that if people have higher levels of internet efficacy, this will lead to a higher willingness to use new technology. This could be your hypothesis. It can also, for instance, be a hypothesis in your master's thesis. Now, this is your hypothesis, and of course you want to test this. So what you then do is you go out into the world and you're going to collect data. Now let's assume this is what your data looks like. Let's say you've tested about 100 people, and for those 100 people, you have measured their internet efficacy, and you've also measured their willingness to use technology. And if you have done this for every person that you have tested, you will get one blue dot in this graph. So in this graph, here we have an x-axis, and here we have plotted people's score on internet efficacy. And as you can see, this might go from -20 till 60. And let's say 60 is a very high score. So here, those people here who have a score around 60, they are very good at using the internet. Probably young people, people like you or like us, maybe. So this is a very high score, but as you can see, there are also relatively low scores on the other hand. So -20, even almost. So this might be a very low score for someone who's not good at all in using the internet. Right, so that's the x-axis. On the y-axis, you have plotted the willingness for people to use technology. And this can also be relatively low, and it can also be relatively higher. And what you're hypothesizing, what you were hypothesizing, is that higher levels of internet efficacy, so higher values on the x-axis, would also correspond to higher values on the y-axis. And when looking at all those data points, this is something that seems to be the case, right? So overall, you could say the higher people's internet efficacy, also the higher people's willingness to use technology. So it seems here that your hypothesis can be confirmed. But of course, for you to be sure, you should carry out a statistical test to be completely sure that this relation that you visually observe here is actually also statistically present in your data. That's what you can do with a simple regression analysis. And what this analysis basically does is that it comes up with a model. And the model in this case is this red line that you see here. This is the model that SPSS, for instance, provides you. And this line is the model that fits those data points best. This line and this model is called a linear model, a simple linear model. This may sound complicated, perhaps, but it's actually very simple. It's called linear because it's a line and it's a straight line. And it's a model because it sort of models all those data points. And this line, you can also describe in a formula. And this is what this very simple formula looks like. So I know some of you might get scared by seeing formulas. Actually, those formulas are not super important on the one hand. On the other hand, here, they are relatively easy to understand, actually. So here what this means basically is, this is a description of this red line. Y simply stands for your outcome variable. So here, the willingness to use technology. X simply stands for your other variable, internet efficacy, which is also called your predictor. Can we predict people's willingness to use technology on the basis of their internet efficacy? So this is a predictor. Then there's this one B value. This simply stands for, this is called the intercept. It simply stands for the point in which this line crosses the y-axis. So here, this is about, this stands for a value of about 5. X is this other variable, right, the predictor, and it also has a certain parameter. And this parameter stands for the slope of this line. So this line can be relatively steep or not, which leads to different parameters here. So the steepness of this line, the slope of this line is represented in this parameter. And then, of course, models are never perfect. So as you can see, this model is not exactly on top of all the data points. That would also be impossible, right? If you would have a straight line, as we have in linear models. So there is a certain error term. The error term simply means not all the dots are exactly located on this line. That's basically the formula for simple regression. In general, in this course, it's nice if you understand this to some extent. If you don't understand it now, please read chapter 9, where it's also explained. If you understand this, this is very nice. On the other hand, for carrying out your analysis in SPSS, it's not so critical that you understand. But if you do understand this more or less, it's sort of a nice check that you sort of know what is going on in regression analysis. Right, so this is simple regression analysis. As I said, in this course, we're going to look at multiple regression analysis. A multiple regression is simply an extension of this form of simple regression. Basically, the main difference between simple regression and multiple regression is that in simple regression, you only have one predictor. So in this previous slide, in this previous example, we had one predictor, right? In multiple regression, there's simply more than one predictors. So in our example, this could be, on the one hand, internet efficacy, but on top of that, 2 more predictors. So for instance, perceived usefulness or social influence. And all those 3 different predictors could all predict, hypothetically, whether people are willing to use a new technology, right? So if you want to know whether all those 3 predictors, all 3 predict people's willingness to use technology, you would do multiple regression analysis. If there would be just one predictor, you would do simple regression. If there's more than one, as in this case, you would do multiple regression. This also means that you could have more than one hypothesis, right? So you can still have the same hypothesis. Higher levels of internet efficacy, people's internet efficacy lead to higher willingness to use technology. And what is nice is that you can now test this hypothesis when keeping the other 2 variables constant. At the same time, you can have a second hypothesis about perceived usefulness, and you can test whether perceived usefulness is a significant predictor of people's willingness to use technology. Same for social influence. If people score differently on how they are influenced by other people, will this lead to a higher willingness to use technology when keeping those other potentially influential variables constant? So when you would use multiple regression analysis, you can test whether several variables influence a certain outcome measure. So in this case, Y, willingness to use technology. And you can control for different variables. Is there an effect of one variable when you keep the other variables in your model constant? And now this is the formula that you will get in those cases for multiple regression. So this seems very complicated, right? But it's basically just an extension of what we had before. Again, you have your Y variable, you have the position in your graph where it crosses this Y-axis. Then your variable 1, predictor 2, predictor 3. So those 3 are 3 predictors, predictor 1, predictor 2, predictor 3. They all have a certain parameter, B to them. And of course, your model is never going to be perfect in those graphs, right? So there's a certain error term as well. So this is the formula for a multiple regression analysis, for multiple regression model. Right. Imagine you have collected data on all those different variables and you have run a multiple regression analysis. Of course, you want to know how good your model is. How good is this line that you have in your graph fitting your data points? This is important information, right? It can be a very good model, but it can also be a very poor model. You can evaluate using a measure that is called R-square. And this is something that SPSS will just give you. So sometimes people call this R-squared or R-square or RSQ. It's basically all the same thing. SPSS will give it to you. And what this measure will tell you is whether your model, so this line that you have let SPSS fit your data, whether it actually predicts variance, so the variability that you have in your data. So remember this graph, right? You have all sorts of different data points, and they're almost all different, right? Every data point is one person, and they all have different responses. So there's quite some variability in your data. What you would like your model to do is to predict whether this variability, whether this variance can be explained by those variables that you have, by those predictors that you have. Now, when you look at those things in those ways, it might now also become clear why regression analysis is treated in a course that's called analysis of variance, right? So basically what you're doing in a regression analysis is analyzing all the variance that you have in your data set and then seeing whether different predictors significantly have led to the variance in the data. And R-square is a way, is a measure that can tell you whether your model, whether your predictors are actually doing a good job. So it's basically the proportion of variance in your data that is accounted for by the model that you have. So in the end, what you want to do and what you can do using this measure is saying things like the variance in X explains the variance in Y for a certain percentage. So for instance, the variance in people's internet efficacy skills explain the variance in their willingness to use technology for, say, 15%. So R-square is a value that always ranges between 0 and 1. So if you need those percentages for your story, for your conclusions, you just multiply it by 100. Then you get a percentage, right? And if your R-square is 0, then of course your model explains no variance at all. Then it's a completely useless model. If your R-square is 1, so the maximum, it means that it explains all the variance in your data. But this actually never happens. There's always this error term in my life. In all the analysis that I've done, this has never happened. There's always some noise in the data. Right, that's the R-square value. This is what you will get from SPSS, and this is how you interpret it. Here's some more illustrations. So let's look at this left part of the slide first. So here, again, imagine those are all your data points. So those are all different people, and they all have a different score. And SPSS gives you the best model for all those data points. That's what you see here in this linear model, in this straight line. But of course, this model is pretty far removed from many of the data points, right? So the model is not, it's the best model, but it's not explaining all of the variance, right? That's also why you would get a relatively low R-square score, in this case of 0.15. So this model may explain 15% of the variance in your data sample. In this right case, you will see that the data points all are much closer together to this model, to this straight line that you have. So in this case, much more of the variance, relative variance, is explained by your model. So your R-square value will be much higher. So in this case, your model, your straight line, explains 85% of the variance in your model. So this is what sort of different R-square values mean in terms of your data set and the model that SPSS is creating for you. All right, and then let's move on Talking about other different important concepts in the case of regression analysis, and actually in most analysis that you will do, most linear models that you will run. And those are, first of all, outliers. So you can imagine that when you're testing different people, some people might be outliers, meaning that they're behaving very differently compared to almost all other people in your data set. And this can be the case, for instance, because they have a huge hangover. They might not fill out your questionnaire in a very serious way, and therefore they might not really look very well at your questions, leading to very different results to many of your other subjects, many of your other participants in your data. Of course, this is not great, right? And this also leads to variance in your data that's not genuine variance. It's just created by noise, by those factors that you don't really have an influence on. So what often happens is that people remove those outliers from their data before they start fitting a model. So if you know, for instance, that some person has not really genuinely, seriously filled out your questionnaire, you can see in your data probably that this is an outlier. And what you could do to get a better model is remove this outlier from your data set. Of course, you should only do this if you have very good reasons to do this, right? You cannot just look at your data, remove half of it, and then all of a sudden have a very nice result. Only do this if you have very good reasons for this. Those are outliers. Those can lead to noise. Those can lead to variance that you don't want in your data. On the other hand, if you're doing statistical analysis, you might remember from your previous statistics course that your analysis has to meet a certain number of assumptions. So in SPSS, it's relatively easy to run an analysis and just look at the output, but you also want to know whether your output is reliable. In the case of multiple regression analysis, there are several assumptions that your model must need to needs to meet. And those you can read about in chapter 9 of the book on linear regression. One is, for instance, the assumption of linearity. This means that you must be able to fit a linear straight line through your data. Sometimes this is not possible. Sometimes you can only fit like a very curvy line through the data. In those cases, regression analysis is not the right method to use. This is something that your assumptions will tell you. Then there's the assumption of normality. Let me not just explain them all here because it's going to be a bit of repetition compared to the chapter. It basically means that the errors that you have, so the error is basically the difference between your data point, between individual data points and your model. So as you saw, all those different data points weren't exactly located on your model, on your straight line, but there's a small difference between those often. If you sum those all up, or if you all put those in a graph, then those values of those errors, so the difference between the value of the error and the line for each individual data point, if you put those all together, they should form this normal distribution that you see here. And often this is the case. That's just another assumption. There's another assumption of homoscedasticity. You can also read about this in the book. Another assumption is the assumption of independence of errors. Errors in your model should be unrelated to each other, which is also often the case. So read about this in chapter 9 of the book. What is most important is that SPSS, the output in SPSS, will give you information about those assumptions and will tell you whether your analysis meets those assumptions. And if those assumptions are met, then you're fine. That's perfectly fine. Then you can interpret your results in a meaningful way. If your assumptions are not met, simply, for instance, because there's a lot of noise in your data, which can happen, then there are things you can do. So you can do different things to, for instance, transform your data or use a different statistical technique. But for now, let's assume that you will meet those, your analysis will meet those assumptions. Okay, so after this lecture, typically you would do the first practice assignment in SPSS. And of course, as you might remember, when you're doing analysis in SPSS, you get all sorts of outputs. So I thought it would be good to briefly discuss some of the output that you get in SPSS, particularly the most important tables that you will get. So let's get back to our example that we had, right? So remember, first we looked at a very simple model where we had one outcome variable and one predictor, right? And this example here refers to model 1. So I've run this analysis, and this very simple example, this very first simple regression example here refers to model 1. What I've also done then is also ran a second model that's more complex. And in this more complex model, again, it would be the same outcome variable. So people's willingness to use technology, to use a new technology. But in this case, as you can see under B here, I didn't just enter one predictor, but I entered 3 predictors. Those 3 predictors that we were talking about before. And the dependent variable, so your outcome variable, is still the same. So it's people's INT, as it is called here, so people's interest in using a new technology, right? Here you see, so I've run those regression analysis using multiple regression. And what you see here is the outcome. And I want you to focus on several important parts of your outcome, of this outcome. And here, of course, for instance, you see this R square value, right? So we spoke about R square values being an indication of how good your model fits your data. And here you simply get this value for the 2 models. First, you get it for the simple model, so model 1. And here what you see is an R square value of 0.147. So if you understand R square now, this means that in this model, in this simple model, 14.7% of your data is explained by the model. So 50% of the variance in your data is explained by this model. Put differently, 14% of variance, almost 15% of variance in this outcome variable is explained by your predictor. If we then look at the second model, you see that this R square value all of a sudden has become much higher, right? So here is 0.466, meaning that those 3 predictors together explain even almost 50%, well, let's say almost 47% of the variance in your data, meaning that this second model is actually doing a much better job than your first model, right? You might think this is not surprising because now there are 3 predictors rather than 1. On the other hand, your predictors could also have been completely useless, right? So the model couldn't have changed. So in this case, it looks like those 3 different predictors explain your data, explain the variance in your data better than just this simple model. And this is something you can see here looking at those p-values. So here, the top p-value, which is 0.000, tells you that this first model is doing a significantly better job than when you would just take a more or less random baseline model. On top of that, your second model is doing significantly better than your first model. That's what this second p-value tells you. Right, so your first model is doing a great job, and actually your second model with the 3 predictors in there is actually doing an even better job. So that's nice. Let's look at one more important table. Of course, you also want to know whether separate predictors have a significant influence on your outcome variable, on people's willingness to use a new technology. Here we first get this for model 1, and remember that in model 1 there was just one predictor, right? And here your predictor is actually significant. So here you get a p-value that is smaller than 0.05, which means it's a significant predictor. So this measure, people's internet efficacy, significantly predicts whether they are willing to use a new technology. That's nice. That's something you can report. Then we can also look at the second model. So now we have all 3 predictors. And again, you see, not very surprisingly, that the same predictor again is still a significant predictor of your outcome variable, not very surprising. The second predictor actually also is a significant predictor. And the third one is also a significant predictor of your outcome variable, because all those 3 p-values are smaller than 0.05. One interesting thing that you can also see here is that you can find out which of those 3 predictors actually is the best predictor for your outcome variable. And this is something you can tell from your beta, from those beta coefficients that we have here. And typically, the higher this value, the better the predictor. If you look at those 3 predictors here, it looks like that people's esteemed usefulness of the technology is the best predictor of their intention to use the new technology, right? So because this is the highest value. So this is the strongest predictor, and then this is the next strongest predictor, and then this is the weakest predictor. This is also something here you can indirectly see from the p-value, right? So this p-value is a bit higher, so that already sort of indicates that this predictor is less strong than the other 2. Right, so this is with regards to the output of your analysis. Remember, I was briefly talking about those assumptions, right? And that SPSS would tell you whether you would meet your assumptions. Well, here you see one outcome of one of those assumptions that are also tested by SPSS. And this is the assumption of the independence of errors. You can read about this in the book. And basically what this means is that whenever this value here is between 1 and 3, which it is at the moment, so this is 1.8, so it's in between 1 and 3, then you can sort of safely assume that this assumption is met. So you don't have to do anything, and you can rely on your the results that you get. And the same for different assumptions. So there's also the assumption of so-called multicollinearity. That means basically that the different predictors that you have shouldn't correlate too much amongst each other. If you have 2 predictors or 3 that all sort of correlate very highly, so they more or less measure the same thing, that's not very good, that's not very useful. That's what this test is testing for you. And here also, for instance, if you look at the VIF column, if those values are not higher than 10, which they are not at the moment, you can sort of assume that this assumption is being met. So then those results are reliable. So you can rely on those results. That's more or less how assumptions work. So SPSS gives you some results of their tests. If those assumptions have certain values, then you're sort of safe. Then you can interpret your results in a reliable way. All right, that was with respect to multiple regression analysis, what I had to tell you. Of course, you can read more about multiple regression, right? So if you find this very hard to understand, again, read the book chapter on multiple regression. So that's chapter 9 in the 5th edition of any Field's book. And you can also look at the videos about multiple regression that he provides through his YouTube channel. And then I'm sure if you've read this carefully and you would watch this lecture again, you would get a much better understanding of what I'm talking about, especially if you also read the chapters in the book. All right, as I said, I would also talk about mediation analysis, but I'm going to do this very briefly because the focus today is much more on multiple regression. Simple mediation analysis is, again, another analysis technique. So far we have been talking about the influence of a certain predictor on a certain outcome variable. So here this would correspond to the influence of, for instance, variable x on variable I. So for instance, the influence of people's internet efficacy on their willingness to use a new technology. And there we found a significant effect, right? So people's willingness to use a new technology was predicted by their internet efficacy skills. Of course, that's very nice, but what in some cases can be going on is that you might think that there is a relation between 2 variables, but it's actually mediated by something else. So you might think there's a direct relationship between 2 variables, but it's actually indirect because another variable is actually mediating this relationship. So this is all very conceptual. So what I typically do in classes is now ask you, can you think of a research question that you would test using mediation analysis? So if you like, you can now pause this video for a minute or so and think about this for yourself. Let me also briefly think about something, like an example of a research question that you would test. Right, let's look at the following situation. So now imagine, I am hypothesizing that whenever you're watching my lectures, this is actually making you happy. Hypothetical example. So imagine you're thinking about, sorry, imagine you're, imagine I'm thinking, I'm hypothesizing, whenever you guys are watching my lectures, this will make you happy. So that would be really nice, right? So I could test this. I could test whether you're watching my lectures, yes or no. And I could test how happy you are while you're doing that on a scale from 0, very unhappy, to 100, super happy. And I could conclude, okay, apparently when people are watching those lectures, they are very happy. So that would be fantastic, right? But of course, for this conclusion to be reliable, I would need to be sure that this relationship is not mediated by something different. So what could be the case is that when you are watching my lectures, you're actually not at the same time watching the news. And because you're not watching the news, this is actually what makes you happy. So there would be an indirect relationship. When you're watching this video, you're not watching the news. So that's the relation between X and M. And when you're not watching the news, this makes you happy. So that's the relation between M and I. Well, if you're sort of expecting that something like this is taking place, so that your relationship between two variables is mediated by something different, this is something you can test with the so-called mediation analysis. And I'm the second reader for many master's theses often. And in many of those kind of mediation analysis are carried out. Then students are expecting that there's a certain relation between two concepts that is mediated by something different. In terms of mediation analysis, what I would like you to do this week is read about mediation analysis in chapter 11 of Andy Field's book. On the one hand, so this chapter is about different things, but I would suggest just focus on the mediation part. There will be no practice assignments this week about mediation analysis, but it would be good that in SPSS you already install what is called the process macro. So SPSS is a very nice program, and it gives you all sorts of options for doing analysis, but in the default, the standard version, doing mediation analysis via what's called this process macro is not possible yet, weirdly enough. But if you want to do this at some point, you will need this macro. And in book chapter 11 about moderation and mediation, there are instructions referring to a previous chapter. In the 5th edition, this is chapter 4, how to do this. And this is, I also did this myself a couple of weeks ago. This is very simple. So you go to a website, you download an extension, and then you can do those analysis in SPSS. You don't have to do them yet, but it's good already this week to install this additional process macro, such that later on during the course, you don't have to do this anymore. So look at this chapter 11, it instructs you how to do this. And then under extensions in SPSS, you can go to, I think it's called utilities. And then if you have downloaded from this website, it's also specified in the book, you can add it, you can install it to SPSS. And then in the future, you will also be able to do those mediation analysis. Right, and they will look like this, but you don't have to do them yet this week. Right, that's what I had to say briefly about mediation analysis. So the focus was mainly on multiple regression and just some basics about mediation analysis for later. Typically, this would be the first half of the lecture, of the very first lecture in this course. And then there would now be a break, typically like 15 minutes. And then the second half would be this in-class assignment, a relatively short in-class assignment. Of course, we can't do that. So what I suggest is that if you have read the book chapters, and if you have seen this entire lecture, that will be a good moment to now do the assignment. And you can find this assignment for week 1 on Canvas. Make the assignment. It shouldn't take you more, I think, than 1.5, 2 hours, probably even shorter if you have everything installed, if you have SPSS on your computer and so on. And then once you have done those assignments, you can look at the correct answers to see whether you've understood everything correctly. So to finish with just a short overview for week 1, this was the topic, as you know by now. Please, during this week, read chapters 9 completely and chapter 11 focus on mediation of that part of the chapter. If you find this all very hard to understand, please also look at the videos by Andy Field. You can just find them on his YouTube page. And here you see the names of those videos that might be relevant. Of course, there's this lecture. You've watched it now. Well done. You've done this for this week very well. And you can work on the assignments. So as I said, first, read the chapters. Look at Andy Field's videos if you need them. Watch this lecture and then see whether you can make this in-class assignment. And then look at the answers. And if you've done everything correctly, then that sort of should assure you that you understand everything for this week and that you're doing well. Also, as I said, and as I put in my email, there are ways of getting feedback if you think things are unclear. During the scheduled session for every week, there will be this Q&A, and I've probably already sent you the Zoom details when you're watching this. And also you can send me an email. So I would very much appreciate it if you have done all those things that are on this slide. So please send me an email via Canvas, either saying everything was perfectly clear, I understood everything and it worked well, or if you found things hard to understand, if you don't understand them after you've done all those things, please let me know. Then I can, in the next lecture or in a different way, help you with this. And of course, I'll also respond to your emails, in any case, Friday afternoon. All right, that was it from my part in this lecture for now. So hope you enjoyed it. I hope you found it relatively clear. And in any case, we'll have contact via the Q&A maybe, and also via email. And I'll see you next time. And now I'll try to stop this video.